The time required for 10% completion of a first order reaction at 298 Kelvin is equal to that for its 25% completion at 308 Kelvin. If the value of A is 4 into 10 raised to the power 5 second inverse, calculate K, okay, we have to calculate K, the rate constant, and at what temperature, at 318 Kelvin, and then activation energy, right? So in this particular case you can see that what we have basically, we have the two different temperatures, that is the T1 and T2, okay, and two different rate constant, that is the K1 and K2, okay, and then we need to calculate the final rate constant K, that is the K final, okay. So this thing we need to calculate at 318 Kelvin, okay, and then we need to calculate the activation energy, okay. So to solve this particular question we need to understand that the Arrhenius equation, okay. We know that the relation of the rate constant with the temperature is given by the Arrhenius equation, okay, and this Arrhenius equation in terms of two different rate constant and two different temperatures, this Arrhenius equation can be written as log K2 upon K1, where K2 and K1 are the rate constant. Alright, so K2 upon K1 equals to EA upon 2.303 R T2 minus T1 upon T1 into T2. So you are expected to learn this equation. This is very important equation, okay. Arrhenius equation in terms of two different rate constant with two different temperatures. All right, so we will use this equation in this particular question and solve the values. All right, so initially let's see what we have, basically what they have given. So initially they are giving you the temperature is 298 Kelvin, okay, at 298 Kelvin. So the reaction was 10% completed, okay, the reaction was 10% completed. All right, and then at 308 Kelvin, the reaction was completed at 25%, okay, 25% completion. So if you see that for a first order reaction, okay, for a first order reaction we know what we know. We know that Kt equals to, you can write the K equals to 2.303, you know, T equals to 2.303 upon K log final concentration, that is the A, upon initial concentration, that is the A naught, right? So if the 10%, if reaction is 10% completed, what does it mean? Okay, 10% completed means that the initial, you can write it as this 2.303 upon K, okay, that is the K, and this will be your log. Initial concentration will be this will be how you can write it, what is the initial concentration and what is the final concentration, okay. So a finally it is let me write this here, A naught, and this is your final, just a minute, okay, right. So this will, we will take the 100, that is the initial concentration will be 100, and since it is completed by how much, that is the 10%, so this will be your 90, okay, this will be your 90. All right, so from this value, we have the temperature, okay, from this value at 298 Kelvin, if okay, at 298 Kelvin, this value we have the is basically this is the 0.1054 upon K. Alright, so this is what we have calculated for the at 298 Kelvin. That is the first temperature that we have. Okay, now the same concept we will repeat for the temperature at the second temperature, that is the second temperature. So for this we will write, that is the T2. Okay, this, suppose this was the T1. Okay, this was the T1 and this is the T2. So T2 will be 2.303 upon K log. Okay, what is the initial concentration? That is your 100. And what is the final concentration that is left? That is your, if it is 25% completed, it means that 75 is remaining, right? So whenever you will solve this particular thing, okay, in terms of log, whenever you will solve, so the overall value that you will get is the 2.2877 upon K. Okay, upon K2. You can say this is your K2, this is your K1. Okay, right? So basically we have these two equation. Okay, that is T1 equals to 0.1054 upon K1, first equation, and this is your second equation. Okay, now if you see in the question, then the question is saying that, what the question is saying, that at these two temperature, okay, this is equal, means the time, that is the time in first case and the time in second case. Okay, in both these cases the time is equal. It means that according to question, okay, according to question, what it is saying, that the T1 is equals to T2. Okay, the time which is required for the 10% completion is equals to the 10% completion is equals to the time required for 25 that is 25% completion. All right, so this is the, now if you write this from equation 1 and 2, just put the values. So this will be your 0.1054 upon K1 equals to 2.2877 upon K2. Okay, now from this you can write the value of K2 upon K1, and the value of K2 upon K1 will be 2.7296. Okay, so this is the ratio of the rate constant, okay, at two different temperatures. That, okay, so this is the ratio. Now we will use the equation that we were talking about here. Okay, so this is your Arrhenius equation in terms of the two rate constant at two different temperatures. Okay, so we will put the value in this particular expression and then we will calculate the final answer, right? So let's put the values over here. So log, what is the value of K2 upon K1? So from the equation you can see what is the value of K2 upon K1. Okay, so that will be your 2.7296. all right, this is the ratio that we have obtained. Now we need to calculate the activation energy, and this is your 2.303. okay, and value of R we already know, 8.314 joule per Kelvin per mole. Now T2 minus T1 upon T1 into T2. So what is the final temperature is 308, initial temperature is 298. okay, that is 298 Kelvin. Let me write it again here. This is your 298 Kelvin. Okay, 298 Kelvin upon multiplying 308 into 298. okay, all right. So now just to do this calculation, and whenever you will take the value of this log, so the overall expression for the activation energy, this will be, comes out to be 2.303 multiplied by 8.314 multiplied by 308 multiplied by 298, and this multiplied by log how much, 2.7296 upon here we will have the 308 minus 298. Okay, so this activation energy will be, whenever you will solve this calculation, this activation energy will be 7664, okay, 7640.096, okay, this joule per mole, right, joule per mole. And if you will convert this into kilojoules per mole, so this will be your 766.40, not 766, it is the what, let me write it again, it is 76 point, okay, this value will be your 76.64 kilojoules per mole, right? So this is your activation energy. So we have calculated the activation energy for this reaction. Okay, now we need to calculate the final rate constant K. Okay, so to calculate the K, at how much temperature? At 318 Kelvin. Okay, we need to calculate the rate constant K. Remember, this is the rate constant K. Okay, this is your rate constant, and this is your Kelvin temperature, right? So we need to calculate it. Okay, we need to calculate the rate constant. So how we can calculate is, we know that the Arrhenius equation, and what we also have is, we have given the value of A, that is the pre-exponential factor. Okay, pre-exponential factor 4 into 10 raised to the power 10 second inverse. Okay, so this is the data that we have. Okay, so from Arrhenius equation, so you people are aware that Arrhenius equation in terms of log can be written as log K equals to log A minus EA upon 2.303 RT, right? This is also the expression in terms of log, that is the Arrhenius equation. Okay, so we need to calculate the value of K, but we know that what is the A. So log A, what is the value of A? A is 4 into 10 raised to the power 10, 4 into 10 raised to the power 10 minus activation energy. What is the value of activation energy? We have calculated the activation energy, and what is the value? The value of activation energy is 76.64 into 10 raised to the power 3. Okay, here we are putting the value, and this is your 2.303 into R, 8.314 joule per Kelvin per mole. Okay, and temperature, what, 318 Kelvin temperature. Okay, so you will see that the units will cancel out, and remember that here we are using the activation energy, and what is the activation energy that we have get is this one. Okay, so that is the in kilojoules per mole, 76.64 kilojoules per mole. So we are writing here 10 raised to the power 3, that is we have put this value in joules per mole, right? All right, because this value is also in 8.314 joule per Kelvin per mole. Okay, so that is why we are putting the activation energy in joules per mole. All right, so whenever you will solve this question, that is the log this one, so the value will be, comes out to be, this value will be, you know, this value, you can calculate this value of this log. Okay, and you can write it as 0.6021 plus 10 minus, okay, this overall calculation will be equivalent to 12.5876, right? So this is nothing but this is the value. All right, so whenever you will solve this value, so you will get 1.9855. all right, so this is your log K. and we need to calculate the k. So k will be your anti-log of minus 1.9855. Okay, so this will be your 1.034 into 10 raised to the power minus 2 second inverse. Since we have the first order kinetics, so that is why the unit is second inverse. Okay, rate constant unit is second inverse. All right, so that's it. Thank you.